Hey everybody, welcome to video number 3 for the cumulative review packet number 9. We left off with number 24, and the last thing I did on the video 2 was I raised everything in here to the third power, or to the negative third. I noticed that because all 4 of these bases have negative exponents, they all have to flip. So these two would end up in the numerator as 3 to the third y to the 12th, and these two would end up in the denominator as 2 to the third x to the 9th. I love when it flips, everything becomes positive. So this problem actually ends up being like the previous one, because 3 to the third is 27 again, 2 to the third is really 8, and now y to the 12th and x to the 9th are where they should be. So my final answer is boxed in green. Number 25, solve the following system of equations. And you can choose to do this by graphing, substitution, or elimination. Based on the way that it's set up, both of these are in standard form, so I'm going to go ahead and do elimination and get rid of the y's, because I could multiply this entire top equation by -4 to make this become a -8 to cross out with this. So if I multiply by -4, I would get 8x minus 8y equals 24, and I recopy the second equation here. These combine to be 0. So I'd have 1x equals 8, or just x equals 8. So then if I would like to find the y value as well, because you remember you can't just find x, you got to find both, you're going to take that 8 and you're going to plug it back in to either equation. So if I go with the equation that I didn't touch, I'm going to take 8 and plug it in here. That's -56 plus 8y equals -16. Add the 56. 8y equals 40. 56 minus 16. So y would be 5. So my final answer as a point is 8, 5. And you can always take that answer and plug it back into both equations to see if it works. Number 26, write an equation of a line that passes through the pair of points. Write your final answer in slope-intercept form, which is y equals mx plus b. Now this is from first semester, I know, but I do know that this is going to help you in geometry, so I keep putting it back on old tests for your sake. So something from first semester you might remember, other than y equals mx plus b, was this point-slope formula that we started with pretty much every time we wanted to find the equation of a line. Before I work with this, though, the piece of information that I don't have is slope. So I'd have to find the slope, y2 minus y1 over x2 minus x1. So if I call this x1, y1, x2, y2, I would have 2 minus -7 over -2 minus -5. Both of these would become addition. So my slope would be 9 over 3, or just 3 over 1. So I would take my 3 and plug it into my point-slope form. I also would then choose whichever point I'd like. I know I did an example like this first semester, and more of you preferred this point, so I will use it. I will plug the 2 in for y1 and the -2 in for x1. So I'd have y minus 2 equals the slope of 3 times x minus -2. And if I keep simplifying this, we're going to get it to be in this form. I'm going to change that to a plus and get y minus 2 equals 3 times x plus 2. I'm going to distribute 3 and get y minus 2 equals 3x plus 6. Add the 2 so that I get the y alone. And voila, my answer is in point-slope form, slope-intercept form, y equals 3x plus 8. Done. It is a good idea to keep going back to this old stuff. It really will help you next year. Speaking of old stuff, graph the following lines using a method you think is best. You can use a table, slope and y-intercept, or x and y-intercepts. Based on the way that 27 looks, this is in slope-intercept form. So my suggestion would be using the slope and the y-intercept. So this is, remember, the point 0, 3. So you'd start up 3 and then move where the slope tells you to. So I think of this as -1 over 4, or down 1, right 4, because the negative's only on one number. So from here, I would go down 1 over 1, 2, 3, 4, down 1 over 1, 2, 3, 4. Or I could go the other way, go up 1, left 1, 2, 3, 4. I can keep doing that. But either way, my line's going to be decreasing from left to right, which makes sense with my negative slope. Number 28, this one, you could do two things. I do notice that the original equation is in standard form, so you could solve for y, get it to look like this, and graph it just like 27. Or, for the sake of review, you could find the x-intercept and the y-intercept, and that's called, well, what we called it first semester was the cover-up method. So if I wanted to find the x-intercept, you cover up 3y and get 4x equals negative 12. If you want to find the y-intercept, you cover up 4x, you're left with 3y equals negative 12. So x would be negative 3 if I divide by 4, and y would be negative 4. So my x-intercept is on the x-axis right here at negative 3, 0. And the y-intercept on the y-axis is down 4, which is at 0, negative 4 as a point. So the line would just be the connect of these 2 points, and that would be the equation for the graph of my line. Numbers 29 and 30. Determine if the following equations are exponential growth or decay. What percent growth or decay? So this was from our last unit. Remember that my growth equation looks like this, 1 plus r to the t, and my decay equation is a 1 minus r to the t. So if the number's above 1, like this example, I know that it has to be exponential growth. But if the base is less than 1, like this example, this would have to be decay. So if I look at the growth one first, if I think about that I need to take this equation and rewrite it to look like this, 1 plus something, I know that 1.14 is really 1 plus 0.14 to the x, which means that my r value is 0.14, which means that my percent growth is really moving the decimal over twice, 14%. The decay equation, however, you would like it to be looking something like 2,000 times 1 minus something to the x to give you the 0.03. So in my calculator, if I take 1 minus 0.03, I get 0.97. So it would make sense that 1 minus 0.97 is 0.03. So that means that this is my r value. R is 0.97, which means that my rate of decay is 97%. Number 31, complete the table of values and graph the points accurately. This looks like it is an exponential equation. And what we did on the previous test was we used the table to figure out what it looks like and then found all this information. So we would plug in 4 to the negative second minus 3, 4 to the negative first minus 3, 4 to the 0th minus 3, 4 to the first minus 3, and then 4 to the second minus 3. So if I start at the bottom, 4 to the second is really 16 minus 3, so my output is 13. So my first point, might go off the graph a little bit, is 213. 4 to the first is 4, 4 minus 3 is 1. So 1 comma 1, input, output. 4 to the 0th is 1 minus 3, so my output is negative 2. So 0, negative 2 is another point. 4 to the negative first is really, remember, the reciprocal, 1/4 minus 3, which is really 0.25 minus 3. So that would be negative 2.75. So I have negative 1, negative 2.75. And then 4 to the second is 16. So 4 to the negative second is 1/16 minus 3. And 1/16 is really, if I write it up here really quickly, 1/16 is 0.0625. And if I subtract 3 from that, I would get negative 2.9375. So my last point is negative 2 comma negative 2.9-ish. So it looks like I'm slowly approaching negative 3. So if I graph these points to the best of my ability, negative 2 comma negative 2.9 is really, really close to negative 3. Negative 1, negative 2.75, a little bit higher up. 0, -2, 1, 1, and then 2, 13. So probably up here somewhere. So it looks like this graph is going to increase very quickly, and it looks like it's slowly approaching -3, but not quite getting there. So my graph this looks like growth to me because it's increasing very quickly from left to right. So I'm going to say that this graph is exponential growth. If I take a look, my y-intercept is at 0, -2. The asymptote represents the line that I cannot cross, but I'm getting close. And so that looks like here at -3. Specifically, it hits the y-axis at -3, so the line is y equals -3. The domain goes forever to the left and forever to the right. So the domain is -infinity to +infinity. And the range, again, is connected to the asymptote. It's the lowest point to the highest. The lowest this graph can get is the -3 almost, and then the graph goes all the way up to +infinity. So -3 to infinity is my range, and the asymptote and the range always are going to be the same number. So last but not least, another example from first semester that I know will come up in geometry, solving a proportion. So if you have a fraction equaling a fraction, you might remember first semester that I said 2/3 is equivalent to 4/6, and I noticed that the diagonals, if you multiply them, were equal. 12 equals 12. So if you have a fraction equaling a fraction, your diagonals are going to be the same number, which means that 6 times 4x minus 6 is going to be the same as 10 times x plus 3, which is more commonly known as cross multiplication. So now, if I distribute on this side and I distribute on this side, we should be good to go. 24x minus 36 equals 10x plus 30. If I move my x's together, I would get 14x minus 36 equals 30. And then if I add 36 to the other side, I would get 14x equals 66. Then if I divide both sides by 14, I don't think 14 goes in evenly, but we could leave our answer as 66/14 and then reduce. Because both of these numbers are even, we can divide both by 2, and if I do so, that would be 33/7 as my final answer for x. Alright guys, if you need to go back and rewatch any examples, feel free to do so. I hope that these videos are a good resource for you, and best of luck studying for your test. Thanks!